So in this video, we will see an example of static keyword in Java. So here I have a class static demo. It has a single instance variable ID and then a single instance method do something. And in the main class, what I'm trying to do is I'm creating one object of the same class and setting its ID property or the instance variable to 102. Then I'm trying to access the ID by the via the object1.id, and then I'm calling the method on the object. Similarly, I'm creating another object, and let me change it, setting a different ID, then accessing the same ID property of the second object, and then we are calling the same method, instance method, on the second object. And if you notice in the method body, we are printing a message on the console that doing something, then this. So this, we know that this is a special keyword, and we introduced the use of this in the constructor overloading, but here we are using this in a different way. This basically refers to the current object that is being used in this context. So whatever object we are using to call this method, this will print, this basically refers to that object, and if we are printing this on the console, then we will see the ID of that object. We will get to know when we see the message on the console, but this in this message on the console, we will see the ID of the object. So we will know actually which object called this particular method. That's why we are appending the value of this, whatever value this is referring to the message. Now, this is pretty simple. We've been doing this since the beginning. So if we run the method, sorry, if we run the main class, then we know that the ID of the first object is 102. Then we see doing something, and this is a kind of an ID of the object one basically. So we see that the name of the class, fully qualified name with the package, then at the rate some uh, integer value, alphanumeric. So that is the ID of the instance that we created, which is object one. And similarly, we see the 110 ID for the second object, object 2. And then when we call the do something, it called this particular method and printed doing something plus another ID on the console. So we know this object is different. So object 1 and object 2, they are different because they have their unique IDs. And each object has its own copy of ID because ID is an instance variable. So each object has its own copy of ID 102 and 110. And similarly, in case of instance method, uh, each method invocation has a unique reference to the object, and that we can see by the value of this. So this is the standard stuff in case of instance variable and instance method. So here we are accessing the property and the method via an object 1 and object 2. Is there any other way to access these things? For example, if I try to do something like this, can we do that? Let's try. Instead of accessing the ID instance variable by object, here we are trying to access the ID directly with the name of class. So this is a compile time error. We cannot do that. The point is, if we have an instance variable or an instance method, we need to create an object first. It must exist. Then only we can access the property or call the method. That is the concept of instance variables or methods. Now, task is to create something that is common, that is shared among all the objects. That's when we create the static keyword. So how do we create static variable? How we declare a static variable? So we use the access modifier, then the static keyword, data type, and name of the variable. So here we are declaring a static variable named counter. And now this counter variable, because it is a static variable, it will be common for all the objects. This particular variable belongs to the class, not to a single instance. So we can access this variable directly. We don't need an object, and because it is public, so we can access it from anywhere. So here in the same way, if we use it by the class name static demo dot counter, and if we run the code, then we see the default value 0. It means we can access the static variable with the class name. So we don't need to create an object. That is the difference number one. So we can access the static variable directly by the class name. All right. Now let's see how does it retain its value uh, between different object invocations or instantiations. So here we see that the ID is an instance variable. So when we created an object number one, we initialize the value 102. So ID is an instance variable, and for object number one, we initialize the value 102. And when we print this value on the console, we see the value 102. And then if we create the object number two, but if we do not set this value, let's see what happens. So here we see the value 102 for object 1, then the message that doing something with its ID, and then we see the ID for object 2, which is 0. It means that because each object is unique, each object has its own copy of instance variable, so ID has been reinitialized to 0 for the object 2. It has been reinitialized. That's why see this 0 on the console. So for a new object, we'll have to reinitialize the value because that will be its own copy. But that's not the case with static. We can the static keyword, or sorry, the static variable retains its value for all the objects. So it doesn't matter which object is it, which object invocation is it, whatever we change in the value, whatever change we make to the value of a static variable, it will be there for all the objects. So let me revert the code here and just run it again to reset the state. Okay, so here we see the value of static, which is 0. All right. So let's use this counter variable so that it's clear what is the purpose of static. Here in the do something method, what we are doing currently, we are printing the message doing something, then the this, which is the ID of the object. Now let's append the value of counter in the same method. So we know by default the value is 0 because it is an integer variable, although it is static, but because it is an integer variable, it will be initialized with a default value, which is 0. We saw this in on the console because we have this print statement. So let me remove it and let's change this value. So before we start or before we create any object, what I'm doing is I'm setting the counter variable to 1. So we did set the counter variable to 1, then we are creating the object and calling the method. Similarly, we are creating another object and calling the method again. Now, if we run the program, So we see the id, then for the first object in the in the method message that is being printed by the method, we see the unique id, which is basically this. And then in square brackets, because we put the square brackets, we see the value of counter, which is 1. And then we created another object with id 110, and when we call the do something second time, we see the counter has the value 1. So we see it retained its value 1 because it is static. In case of id, when we did not initialize the value of id, the id was 0 because the instance variable was reinitialized for the second object. But because it is a static variable, it belongs to the class, it retained its value. It's not 0 for second object. And if, for example, at this point of time, if we change the counter variable to 2, let me just put something else so that it's visible. So here we see for the object 1 it is 1, and for the object 2 it is 2. So the point is, that's why we use the static variable, because it is shared, it is common, and it does not lose its value. It belongs to the class, not to the object. And here we can see that when we created initialize the counter with 1, it was same for both the objects, but when we change the value, it is visible for the second object only. And it's not reinitialized by Java to its default value for another object. Similarly, if we have a static method, so we write the access modifier, static keyword, then return type and name of the method, and we can put anything we like. Call static methods, we simply use the name of the class and the name of the method. And we see the message on the console. So that's how we call a static method. We don't need an object, we just need the name of the class. So we saw a couple of things and different use cases with static keywords, and that should be all on the static. Thank you.